Okay, so the next section we're going to do in the book is section 8.5, talks about integration of rational functions by partial fractions. And to set the stage here a little bit, if we think back to just what we know about fractions in general, when we're not saying, well, I don't like fractions, and if I want to deal with fractions, I deal with a calculator. Think about things like getting common denominators. Let's say that I had 1/5 plus 1/3. And of course, I need to get a common denominator there. And in order to do so, I multiply here by 1. It just looks like 3 over 3. Here by 1, it looks like 5 over 5. And the results that I would get here would be 3 over 15 plus 5 over 15. And that would give me 8 over 15. Now that's the basic idea of getting a common denominator and being able to add together those fractions. But what if we started at this place? What if we said, well, 8 over 15, how can that be rewritten as a sum of two fractions? Well, we can see this is where it came from, so we know that, but we also could have figured this out if we didn't know that. If we said, okay, we have that 15 on the bottom there, and 15, we know, is 5 times 3. And as a result, somewhere somebody got common denominators in order to get 8/15, therefore they had something, which I'll just call A, over 5, plus they had something else, potentially else, over 3. Those needed to be the two things that were being multiplied together in order to get the common denominator. And so, well, what does that tell us? That tells us that, well, if we follow through this process, we would have 8 over 15 equals 3a over 15 plus 5b over 15. Now, all these things being over 15, I can just multiply this whole thing times 15. I don't really care about the denominator. Once it's equal on each side. And I end up with an equation that just simply says this. Now, are there different possibilities for what could be A and B? There could be. In this particular case, we could say, well, we could have had the case where A was 0 and B was 8 over 5, right? That would be another way to get 8 over here. We could have had the case where A is 2, and we could figure out, we could plug in an A, figure out what the B is. In fact, this is an equation of a line right here. But we can see that if we're talking about things like whole numbers, it's very obvious that A and B could be equal to 1 in order to give us 8. I'm not going to go into a whole lot more of that, but that is where this idea that we're going to do today, called partial fraction decomposition, is going to come from. We take a fraction like this, except we're not going to have one with just numbers, and we're able to decompose it and figure out where it came from. And the power of that is if we're given a rational expression, meaning a fraction, that we don't know how to integrate, it is possible for us to break it into two separate fractions, and then those potentially we do know how to integrate. And so that's what partial fraction decomposition is about, and what we're going to do in this section 8.5.